Fusion devices present challenges and opportunity with their high power densities and temperatures. High power densities can lead to compact design, reducing capital cost and making fusion energy more attractive. However, they also intensify the heat exhaust challenge. Elevated temperatures in working fluids increase electric power conversion efficiency, but impose strict material requirements and add complexity to capture and conversion processes. UNITY-1 addresses this paradox by demonstrating the feasibility of high-temperature heat extraction at 1000 degrees Celsius, optimizing the fusion thermal cycle and reducing costs. UNITY-1's modularity offers significant advantages, enabling seamless integration and scalable pathways to boost high-temperature heat extraction efficiencies.